Yes. Come here. Come to the board. In motion chapter, we studied about distance. What is distance? Can we recollect?
Yeah. It is the actual path covered by an object.
Yes, actual path covered by an object. We can call it as a distance. What is displacement?
The shortest distance covered by an object.
No, exactly. Displacement.
Displacement only.
Again, repeat.
The shortest distance covered by an object.
Yes, the minimum path traveled by an object or the shortest distance covered by an object called as a displacement. What is the difference between distance and displacement?
Distance displacement. Distance is a scalar quantity and
Very
displacement
good.
is a vector quantity.
Yes, displacement is the vector quantity.
Vector quantity.
Now, later on we studied about uniform motion. What is uniform motion?
Uniform motion is that when the object covers equal distance in equal interval of time.
Very
It's
good.
called uniform motion.
Excellent. Non-uniform motion?
Yeah, it covers unequal distance in equal intervals of time, or we can say that unequal, the time will be different and like vice versa.
Excellent. Later on we studied speed. What is speed?
Speed is the actual path covered by an object per
In unit time. Means distance by time.
Distance by time.
What is the units of speed? Meters per second
Meters per second.
or?
Kilometer per hour.
Very good. Kilometer per hour.
Yeah.
Then what is velocity?
Velocity is the minimum distance traveled by an object per unit time. That is
Yes.
displacement by time.
Displacement by time. Very good. Then what are all the units of velocity?
Velocity is,
Meters per second
yeah,
or kilometer per hour. 1 kilometer per hour. How many meters per second? 1 kilometer, 1000 meters.
yeah.
1 hour,
Or
3600 seconds.
Oh,
Not 60 seconds. 3600 seconds. So once if you do the simplification, 5 by 18 will come.
18, yeah.
Finally, 1 kilometer per hour is equal to 5 by 18 meters per second. Clear?
Yeah.
Next, we studied about acceleration. What is acceleration?
It is the rate of change of velocity.
Yes. Change of velocity by time. Change of velocity by time.
Time.
So acceleration A is equal to V minus U by T.
Minus U by T.
Units. Meters per second square or kilometer per hour square. Yes. Now, what is average speed? Have we studied?
Yeah.
Average speed?
Average speed, no.
Okay, I'll explain. Average speed. Average speed is equal to total distance by total time. Total distance by total time. I'll explain you how it is. A car from point A started. It reached to point B. Example, between these two 5 kilometers. From point B to point C, 7 kilometers. From point C to point D, 3 kilometers. Different points, different distances. Finally, a car traveled from A to D. From A to B, it had traveled in 1 hour. From B to C, only 30 minutes. and C to D only 20 minutes. This is the time between two stations. Now what is the average speed of the car? Which means total distance 5 plus 7 plus 3 by, we have to convert into hours. If not, meters and seconds. Clear? So this is the average speed meaning.
Yeah.
Next. Can you able to note it?
Yeah.
Once if you write it, you won't forget. This is also important. Average speed is equal to total distance by total time. Next. Average velocity.
Yeah, this we studied.
Yes, average velocity. Average velocity in the sense of initial velocity plus final velocity by 2.
By 2.
These units also again meters per second or kilometer per hour. Units won't be changed. Even the average speed also kilometer per hour or meters per second. Okay.
Yeah.
Next, acceleration. Acceleration is equal to velocity by time or rate of change of velocity by time. Anything is correct. If initial speed is 0, then obviously a is equal to v by t. Clear?
Yeah.
Next, graphical representations. Graphical representations. Can we able to do the motion on an object in a graph? We need to see. Say an example. Daily you are going to school. You are going by cycle. Say an example, bicycle you are using.
Yeah.
Now you are parking inside of the school gate at the time of 8:30 a.m. Still up to 3:30 p.m. cycle will be still there itself. It won't move.
Okay.
Yes, an object is there in a certain place from a long time. Once if you do the distance time graph, on the x-axis time t, on the y-axis distance d, you placed it a certain distance. But now time is increasing, the distance is not changing. Okay.
Yeah.
So once you can make a line over there, this graph indicates stationary motion. Stationary motion graph or object at rest. Okay.
Yeah.
Next, uniform motion. Already we discussed what is uniform motion. If an object travels equal distances, equal intervals of time continuously, called as uniform motion.
Yeah.
For this uniform motion, on the graph, on x-axis time t, on y-axis velocity v or distance d, whatever. Now equal or else distance time graph only can mention. Equal distances in equal intervals of time. This graph indicates uniform motion. Okay.
Yeah.
Non-uniform motion. Non-uniform motion. Time t, distance d, non-equal distances and non-equal intervals of motion. This is the graph. Okay. So this is non-uniform motion. Clear?
Yeah.
Next, equations of motion. Equations of motion. what are the equations of motion we are going to study. You know, an object, when it is started, that time velocity, initial velocity u.
U.
Okay, initially, what is the velocity? Called as initial velocity. Now, which is running on the road. Certain time, there is a velocity, final velocity v. Then it will be stop again. Okay. Now, between u and v, there will be an acceleration. An object changed the place, the distance s, in unit time t. Okay. Now, as per the acceleration is equal to change of velocity by time. Yes, na? Change of velocity by time. Acceleration a is equal to change of velocity v minus u by t. So v minus u is equal to a into t. V is equal to u plus at. This is the first equation. Hope you understood.
Yeah.
Please write it down. Next equation, S is equal to ut plus half at square. This equation we have to prove. On the x-axis, time t, y-axis, velocity v. Okay. An object from point A, it started with initial velocity u. It reached to point B, final velocity v. So it will take some time t. Okay, this is time t.
Yeah.
This is O. Now whenever this is the final velocity v, we can note it on the y-axis. This is the point. That's right. This is the final velocity v over here, some value. Now we need to calculate the distance s between A and B. That's right. The s we have to calculate. Now cut a line, join a line on this perpendicular line. Name it as a C and a D. Clear? Now the distance traveled by an object S is equal to the area covered by triangle ABC and rectangle OACD. That's right.
Yeah.
The distance traveled by an object between A and B, S is equal to the area of triangle ABC plus area of rectangle OACD. Clear? Area of triangle ABC half into base AC into height BC or CB, whatever. Okay. Plus area of rectangle OACD, which means OA into OD. Now that is equal to, what is AC value? AC is perpendicular to OD, right?
Yeah.
Means time t. Half into time t. Now this BC value, which means this value, both are opposite sides. Yes, from here to origin, that is final velocity v.
Yeah.
From here to here, that is u. What about this distance? V minus u. So BC also v minus u.
Yeah.
V minus u plus OA value u. OD value time t. Now half into t into v minus u plus ut. From the first equation, you know that v is equal to u plus at. From the first equation, v minus u is equal to at. Substitute at value over here. Half t into at plus ut. That is equal to half at square plus ut. So finally s is equal to ut plus half at square. Hope you got it.
Yeah.
I guess this one you are feeling bit difficulty. It's not difficulty exactly. We need to step by step has to follow. Next equation. V square minus u square is equal to 2as. This also in simplified manner I explain you. On x-axis time t, y-axis velocity v. An object from point A started with initial velocity u. It reached to point B. It's a straight line, not a curved line. Point B with final velocity v in unit time t. Okay. The distance covered by an object AB here S is equal to area of trapezium OABC. Area of trapezium OABC. Now for that formula, OA plus BC by 2 into OC. What is OA value? Initial velocity u. What is BC value? BC means from here to here. Final velocity v by 2 into what is OC value?
T.
Time t. Very good. So you can write it v plus u by 2 into t. From the Newton's first equation, v is equal to u plus at, v minus u is equal to at, t is equal to v minus u by a. Once you substitute here, v plus u by 2 into v minus u by a is equal to s is equal to v square minus u square by 2a is equal to s. Therefore, v square minus u square is equal to 2as. This is the equation. Understood?
Yeah.
Can I repeat or completely understood? Got it? Fine. Note it down without seeing the board. The last one, uniform circular motion. Uniform circular motion. How to define this? If an object travels equal distances in equal intervals of time, circularly called as uniform circular motion.
So could you repeat?
If an object travels equal distances in equal intervals of time, circularly called as a uniform circular motion.
Okay.
Got it?
Yes.
This is the theory. Now, from the motion chapter, what are all the Cbse questions they'll ask? We will discuss now. I'll send a file to you. State the meaning of uniform circular motion. Can you say?
If an object travels equal distance in equal intervals of time circularly, then it is uniform circular motion.
Very good. Why is the motion of an athlete moving along the circular path, an accelerated motion. Can you answer?
I understood the meaning, but I don't know how to write it in the physics thing, words.
That's what I'm making you practice now. This question, how you can able to answer? Okay, what is your internal meaning? What you understood from this question?
Okay. So it's asking why is the motion of an athlete moving along the circular path an accelerated motion?
Yes.
So we know that acceleration is the change of velocity by time.
Okay.
So when a person is accelerating, meaning it is moving with a certain velocity.
Mm-hmm.
So it's moving in a circular path.
Mm-hmm.
So it's asking why is the motion of an athlete moving along circular an accelerated motion?
I'll explain. While in the circular path, while athlete running in the circular path, each and every point there is a direction is changing. Obviously the speed will be changed. Yes, this is the cause for the accelerated motion.
So can you repeat and write it down?
Yes. If an athlete runs along the circular path, each and every point the direction is changing. Hence, speed will be changed, which causes to accelerated motion. Which causes to accelerated motion. Okay. Next, third question. State the type of motion represented by this path, distance time path. What type of motion it is? Uniform. Uniform motion. Perfect. Fourth one. If the acceleration of a particle is constant in magnitude but not in direction, what type of a path does the particle follow?
A non-uniform path.
Again, if the acceleration of a particle is constant in magnitude but not in direction, what type of path it will be? Circular motion. Yes. In circular motion, the direction is changing, but acceleration constant only.
So we can also say that like non-uniform path.
Non-uniform path is different. Non-uniform path meaning itself different. It won't cover distance.
Okay.
Next, two cars A and B have their displacement time graph. Which car has a greater velocity? Yes, please. Which one?
Is it A?
How you expected it is A?
Because I related that the velocity meaning the minimum distance.
Okay, fine. Displacement by time graph only. Displacement by time only velocity. Because displacement time graph indicates velocity. But which car greater velocity? Come to the whiteboard. I'll explain.
Okay.
This is time. This is displacement. This is car A. This is car B. They're given like this. Now, which velocity is very more, car A or car B? Coming to car A, the displacement is more, time is less. Yes, velocity is equal to displacement by time. Nominator is very more, denominator is less. Coming to B, displacement is less, time is more. If nominator is less, what will happen? This will be reduced. Clear? So which car having greater velocity? A car. So this is the way we need to find out.
Okay.
Hope you got it. How to answer the Cbse questions. Now, a particle is moving with in a circular diameter 5 meters. What is its displacement when it completes 1.5 revolution? What is the answer? Okay. I'll make you to do this. Whenever we discuss the distance and displacement, we need to solve a few problems, then you may come to know about this. An object from point A, it reached to point B. Okay, that is 3 kilometers. From point B to point C, 10 kilometers traveled. Okay, what is distance and what is displacement of this?
Distance is 13 kilometer.
Okay.
And displacement also.
Displacement also. Very good.
13.
Yes. In the second case, it went to C and it came to back D. 3 kilometers it came back. Now, what is distance and what is displacement?
Distance is 16 kilometer.
Distance 16 kilometer.
And
displacement
is 8 10.
10. How you calculated 10?
Because it went to A to C and then back to D, so we here have to calculate from A to D, not
excellent. That is 10 kilometers. 10 kilometers. Third problem I'll give you. A car from point A to point B, it went to 3 kilometers. From point B to point C, 4 kilometers. Now what is distance and what is displacement? Displacement
distance is 7 kilometer.
Okay.
1 minute. And displacement is 5.
Displacement is 5 kilometers. How you calculated 5?
By Pythagoras theorem.
By Pythagoras
A
theorem.
to C.
Very good. This also you can able to solve. An object from point A with r radius, it reached to point A. So how much distance and how much displacement?
Distance is, displacement will be the same, which is 0.
Okay.
And is the distance 2r?
No, 2 pi r.
Pi.
2 pi r, circumference of a circle. Now, once you read this question, I feel you can able to answer it now. Can you repeat your doubt? How you are confusing?
like it's saying that find its displacement after 1.5 revolutions.
Okay,
So first I'll just try doing
try.
So like suppose this is given, this is 5, and it's saying that from it's completing 1.5 revolutions. So if one revolution it goes and it will come here, it will be 0, and the half again it will come here.
Yes.
So this one only.
Means diameter itself.
Yeah.
Diameter itself.
Hmm.
Next question, please.
What kind of motion of a body is represented by the graphs?
Yeah. What's the first question? Like in that A, which graph it will indicates?
Distance time.
This graph indicates
Both are distance time.
what type of motion it is?
This is uniform.
No. We discussed.
Stationary.
Yes. Stationary motion. Second,
Second, non-stationary.
one is uniform, then stationary. Yes, na?
So, but how is this like uniform?
Because the first from origin to some extent level, that is uniform motion.
Yeah.
Then after it comes to rest.
Okay.
That is the way. Eighth question. Eighth question.
The direction in which an object moves is given by the direction of velocity of the object and not by the direction of acceleration. Give an example to justify this statement.
Yes, ma, please. What's the doubt?
Like, what is the direction of velocity and direction of acceleration?
Means velocity direction and acceleration direction both are different in this case. You need to give an example. Can I support you?
Yeah.
If you throw the ball topward direction, the velocity will be topward direction.
Yeah.
But the acceleration due to gravity downwards direction.
Oh, okay.
So that way you need to answer. Next. Ninth question.
Velocity time graph. Foundation. Uniform motion, no?
This is not a uniform motion, uniform acceleration because velocity time graph.
Velocity. Uniform acceleration.
Then and there itself you have to change the wordings. 10th question. The graph is downwards. The question is, velocity of a particle moving along a straight line in certain time interval as shown in below. What is the distance traveled during acceleration? What is the distance traveled during acceleration? The question is during acceleration.
Acceleration.
I'll answer you. You can see that the graph is starting from 0. In 1 second it reached to 10. Then after it was stopped only. During acceleration in the sense of that graph only. Uniform motion graph is there now.
Yeah.
So that distance we have to calculate. How to calculate? Velocity is equal to displacement by time or distance by time. Distance is equal to velocity into time. So 10 into 1, 10 meters. Cbse questions, we need to identify clearly. Answer is very simple. That is also the answer, but final answer may be correct. You may carry 1 mark. But learn the concept. 11th one. Name the quantity measured by the area occupied below velocity time graph. Not necessarily below velocity time graph, generally velocity time graph. Name the quantity measured by the area occupied by velocity time graph. Name the quantity, which means name the physical parameter. What is the physical parameter?
Velocity time graph.
What velocity time graph indicates?
Velocity time graph tells
Acceleration.
the acceleration.
That's it. Answer itself, acceleration. Got it?
Yeah.
Under what condition is the magnitude of distance and the displacement are equal?
When they're traveling in a straight line.
Excellent. When traveling in a straight line, both are equal. 13th question. An object starts with initial velocity u and attains a final velocity v. The velocity of object is changing at uniform rate. Write the formula for calculating average velocity.
Formula is u plus v by 2.
That's it. Now 14th one. A body thrown in a vertically upwards direction rises up to a height h and comes back to the position of start. Calculate the total distance traveled by the body and the displacement of the body.
H plus h.
What is that?
Because it's thrown up in a vertical upward direction, which the height is h, and it comes back in the again the downwards. So it's h plus h.
Excellent. So 2h is the distance.
2h, yeah.
Displacement of the body.
Displacement would be 0.
Correct. Now, bit scroll it down. You can observe similar way the 2 marks questions. Previous year questions. Have you observed?
Yeah.
A cyclist travels a distance of 4 kilometers from P to Q.
Okay, that one. Okay.
Only previous year questions we are discussing.
And the before one?
No, later on you can solve as exercises. Okay. A cyclist travels a distance of 4 kilometers from P to Q and when moves a distance of 3 kilometers at right angle to PQ. Find the resultant displacement graphically. You need to imagine the graph and try to calculate the answer.
So is it like this for, like there's a, when we draw the graph, and then suppose when the O point where we mark, that is P, and the up one, the distance one is Q. So P to Q is 4, and then it's saying that then it moves a distance of 3 kilometer at right angle to PQ, meaning let's say one more point as S.
Okay.
So from that we make one more line.
Okay.
That one is 3.
Yes.
Right angle to PQ. So we don't know the value of PS. So that we have to
Okay,
find.
once you see the board, you may understood in a different way. Now this is the Pythagoras theorem, na?
Yeah. I drew in my notebook like that.
Yes.
I drew it like this. Like this is 4 kilometer the distance. This is Q and this is P. And suppose this is S. So the right angle meaning
Yes.
it
No, not that will be 3. Q to that point is 3.
So this one.
Yeah. From here to here, this is 4. From here to here, this is 3. Okay. Now they are asking from here to here.
Oh, okay. I thought this did.
Yes, I feel a few seconds left, Saloni. Yeah. We'll meet in the next class. Yeah. Then we will discuss about the next chapter. Yeah. Once you can give me the ratings and remarks, please.